Look, thanks for coming. We've got a really, I think, other than the moderator, an excellent panel today with a public sector representative, a nonprofit representative, and one of the real things, a young coder. The nominal name of the panel is STEAM Ahead. They added the A for arts to science, technology, engineering, mathematics. And what we're going to talk about programs that work, how people get encouraged to enter these programs, and things that cities and nonprofits are doing. So first we have Gabrielle Fialkoff, who is a senior advisor to Mayor de Blasio and the director of Office of Strategic Partnerships. A keystone project that she has led is CS for All, which is a 10-year, $80 million public-private partnership to train 5,000 New York City teachers in computer science by 2025. Gabrielle? Next is Jim Clark. He's the president of the Boys and Girls Clubs of America. There are 4,300 of these clubs. They serve 4 million young people every year. They started a STEAM program, and he keeps the A in there intentionally for arts. I think in 2014, and about half of the clubs now have computer science and science and technology training programs, and the goal is that all of the clubs will have them by 2020. Next is Tanmay Bakshi, who is an unpaid but valued advisor to IBM Watson. Tanmay started writing programs when he was 5 or 6 years old, and he's written a couple of books, including one on the Apple technology, and others are coming, I gather. He's given TED Talks. His how-to YouTube videos those channels have 270,000 subscribers. He's here just came from Dubai. He's stopping here in New York, and he's headed to Malaysia next, where he gives master classes and presentations and he has a narrower goal of inspiring and helping 100,000 beginners to learn to code. And I think from when he talked before, I think he's got that number now up to about 8,000 that he's dealt with directly in small groups or with email assistants and the like. And next we have Tanmay, the star. And we have a late entrant, Miguel Gamiño, who is the departing CTO of New York City. And he's joining Mastercard, and he is ending, I guess almost a decade-long stint of public service, starting with being had the same kind of job as CTO at El Paso and then San Francisco. So Miguel, thank you for joining us. Gabrielle, let's start with you. CS for All. Explain the thinking behind it, how it came to pass, and sort of what the goal is.
Yeah, thank you. Well, in the de Blasio administration, everything we do is geared towards addressing inequality. And so in creating access and opportunity for all New Yorkers. And when we arrived in 2014, we found that only 54,000 of our students were receiving any computer science education out of 1.1 million students, less than 5%. And those that were often classes in the specialized schools, white, male, white boys predominantly, and clearly we know that the tech sector is growing in New York City in leaps and bounds, 57% growth in tech jobs between 2007 and 2014. Department of Labor says there's most likely to be a shortage of 200,000 tech jobs by 2020. And really the skills that computer science education brings to our young people, we were speaking about backstage, the soft skills, what I call the power skills, these are essential for learning today, addressing achievement gaps. So less than 5% of our students receiving computer science education just was unacceptable, frankly, for the city of New York. So we made a commitment, a public-private partnership called Computer Science for All, $81 million partnership with the private sector, 50% funded publicly, 50% privately, to bring CS education to every student over 10 years. And the way we're doing that is by training our teachers. We'll train over 5,000 New York City public school teachers in computer science and roll this out over 10 years and bring it to every grade band. We're piloting elementary multi-year sequence, which did not exist at all, and rolling it out all throughout the school system.
Okay, thanks. We'll have a few follow-up
Yeah.
questions on that later. But Jim, talk about this STEAM program that you've done in the context of the Boys and Girls Clubs. I mean, this is needed, but also for your institution, a bid for relevancy, presumably, right? And to keep going. And the other thing is, I was wondering if there's been any historical precedent. I mean, after Sputnik, was it, we think of that kind of whole math and science, big pushes, largely both federal and then school curriculums, but there may have been this same kind of thing, rocket programs, right? Whatever it was. But I mean, give me the sort of the rationale behind this within the context of your institution and then how you're going about it.
Sure. Well, first of all, Boys and Girls Clubs is an out-of-school time program, so after school and then during the day in the summer. So a little bit different than what Jennifer is talking about in the sense of our time space. So same issue, though, that kids, especially those who need us most, coming from challenging economic environments or under-resourced communities, didn't have access to a lot of the, at least tools and or programs that are going to be so necessary with 21st century skills and workforce readiness later on. So somewhat the same issue. To your question, though, as we step back and look at it, we serve about 4.3 million youth a year, 4,400 locations around the country, 61,000 staff. So yes, in terms of the need, extremely high when it comes to STEAM, and certainly that also cascades or ladders right into the workforce readiness component. And when we think about especially teens today, this is about a job. This is about workforce. And Jennifer was exactly right. The jobs of the future are all going to have a component of science, technology, engineering, arts, and math. So you start with that baseline of who we serve, where we are, and then there's a big gap. So we're not school, but we need to augment, supplement, do the same type of initiatives so that kids, especially those coming from challenging situations, have this access. So, the Sputnik moment, if you will, really emerged, I think, as technology became a much bigger part of everyone's lives. It doesn't matter if you're coming from an economically challenged situation or wealth. Yes, there's haves and have-nots, but all are facing the same issue when it comes to digital literacy. So yes, we realized simultaneously we needed to take this on. The early years were tech centers, right? This was the digital library approach. Now it's all device-based. So we've emerged as well over time. And the programs and different tools that we've brought to bear in the after-school hours focus on soft skills, a way of thinking in terms of what kids need to be prepared with for these jobs of the future, but then also the hard skills when it comes to true technology. And we have programs all along the way from computer science, coding, which is kind of the entry level, all the way to digital literacy, and then robotics, and everything you can imagine in between. And as you said, about half, 50% of our facilities have a program or some kind of experience today, and we want to scale that to all in the next 4 or 5 years. So that's the challenge in front of us. And you're right about relevancy as well. Boys and Girls Clubs have been in existence for 158 years. We are a legacy enterprise in this country. But what we have always been successful with is remaining relevant and contemporary in the lives of youth today. So as we pivoted from a social rec environment several years ago to one with core competency development and academic success, good character and citizenship and healthy lifestyles, along with that pivot was the technology piece, which obviously today is critical when it comes to developing tomorrow's workforce. So we marry a lot of what we do with the workforce readiness skills and the critical thinking skills. You call them the power skills, the soft skills, if you will, innovation, creativity, problem solving. All of this is married with every one of the programs we have when it comes to technology and science, math, and engineering. Last thing I'll say is summer. We also, about 4 years ago, took on summer learning loss. And inside of that were two key components of math and reading. And so the math piece, obviously a direct hit when it comes to STEAM or STEM. And therefore, when we look at kids that typically had 2-3 months of learning loss in the summer, the whole idea of bridging or stemming that loss was what we focused on. Right, exactly. So,
Tanmay, why don't you tell us a little bit about your story? You started programming at 5 or 6. Sort of what got you hooked, and what was the thing that is continually satisfying for you? I mean, people talk about code is it's a building material without material constraints, right? And if you can imagine it, you can code it and so forth. I mean, that is is broadly is the appeal. But just walk us through your introduction to this, and I gather your father is partly to blame, right?
Yes.
So just and give us that, and then I'll have another question.
Sure, absolutely. So, I mean, as you mentioned, I originally started coding when I was around 5 years old. And really the reason this was is because my dad used to work as a computer programmer. And so as you can imagine, me watching him program almost all day would be so fascinating to me that I really wanted to find out more, what goes on in the back end. Even just the computer displaying my name on the screen, adding 2 numbers, it would be so fascinating to me. So my dad saw that curiosity, he introduced me to the world of programming, and ever since then I've really been hooked to technology and computers. And especially when, like, for example, when I was 7 years old and I was in grade 3, I needed to practice my times tables because there was a test coming up. And so I created my first real Windows application to help me practice my times tables. And so these sorts of applications really hooked my interest. And actually, when I had my first iOS application, T-Tables, which helps you learn your multiplication tables, accepted into the App Store when I was 9. Of course, at the time, I continued working with, the Apple platform, iOS app development, but I always felt that there was something lacking in technology. It would sort of bore me at times over time, and the reason was because I felt like it was very literal, right? The moment you code something in, it immediately starts becoming obsolete. It doesn't ever adapt to new data, new circumstances, new users. It doesn't ever adapt. It's the same thing that you've coded in. And so one day, when I was 11 years old, I was actually uploading a YouTube video, and I actually stumbled upon a documentary on IBM Watson playing Jeopardy! And so that was my first sort of gateway into the world of artificial intelligence, and ever since then, I have been hooked to how to apply artificial intelligence to numerous different fields. Nowadays, the fields that I'm most interested in applying them are fields like healthcare, where I know they can, save and augment millions of people's lives. In fact, as you mentioned, I actually have had a goal for the past around 7 years that I've been working towards to reach out to at least 100,000 aspiring beginners and help them along their journey of learning to code and innovate along their journey of learning to code. I'm already around 8,200 people there, always working towards it through numerous different media. And really the reason that I'm working towards this goal is because, as I mentioned, sort of my YouTube channel, which is where I love to, share whatever I learn about these wonderful technologies. Every single time I upload a YouTube video, there are always hundreds of people reaching out, asking questions like, how can I get into coding? How can I go to the next level of coding of artificial intelligence? And it's not even just one demographic either. It's all different kinds of people, whether it be people from a very professional background, working with artificial intelligence in professional companies used by, for example, the New York Times, whether it be beginners who want to get into artificial intelligence. In fact, actually the youngest person who's ever reached out to me is around 8 years old, and I believe the oldest person who's reached out to me is actually around 74. And so it's a huge range, and so I absolutely love taking whatever I learn about these technologies, sharing it with as many people as possible, and working towards goals like these, which is of course why I'm such a great supporter of initiatives like STEAM and STEM.
Thank you. We will follow up. But Miguel, let me ask you, since you started in the startup world and then went into the cities, what did you find there in terms of technical skills and bringing people in? And you've done this long enough now that I assume things have changed.
Yeah. Oh, yeah.
In terms of what's coming. Give us a little. kind of what you've observed as you're walking out the door to private science.
Yeah. So I think the number one thing that I've seen is how the pervasiveness of technology is increasing. And you mentioned that there's several different industries where technology is applied. In fact, I think technology isn't just an industry, it's the future of every industry. It's not just part of some people's life or career choice. At some point, it's going to be part of everybody's life. And I think to the point of reaching out to those communities that might not see it as an obvious pathway, really, really important that that continue because of this pervasiveness. And you just said many, many things that are very inspiring, but the one thing I want to applaud you for most is sharing the inspiration, right? Because it's not just what you're going to code, but it's the 100,000 people that you inspire to do. That's really important to that. And maybe people who can be introduced to it by YouTube who might not see it in a classroom in a more traditional sense. So I think the fact that it's going to become more pervasive requires that we have people like you and programs like CS for All and organizations like yours to really, we need everybody involved. We need everybody to feel like it's either a pathway to their contribution and success, but at a minimum, understanding that it's a real part of the future of society and kind of a way of life that we're all going to experience and encounter one way or another.
Tanmay, let me ask you, I mean, you're obviously, a bright, enthusiastic young man, probably representative of next to nothing in terms of policy, in terms of getting huge numbers of people in STEM, right? And it came effortlessly for you, right? There are not many people that are going to see their father hunched over a machine and be inspired, right? When you talk to beginners, these people you're trying to draft, what works with them? What is the appeal that, piques an interest that starts to become an on-ramp?
Sure, absolutely. Now, as you know, the main technology that I love working with is definitely machine learning technology, artificial intelligence technology. And so really what I find is it really depends on the types of people that we're talking with. Like, for example, a little while ago, I was in Iceland at the University of Reykjavik. And the types of things that would really interest people at a university, students at a university, would really be different from, say, a grade 4, grade 5 class. Like, for example, a little while ago, I was in the Avalon Public School in Australia, and while I was there, really what I find piques most sort of kids' interests and gets them into this kind of field is definitely working with interesting technologies in an interactive way. You see, when we're introducing coding to kids, we can't do it like we've been classically teaching every other subject. We can't do it like the way we introduce math or science or language. It has to be interactive, it has to be hands-on, and really what I say is that no matter what, you need to start small, start easy, and really start playful, right? Like, for example, you see there are a lot of initiatives bringing, say, Scratch, which I'm sure you've heard of, a block-based programming language, to kids. And starting at a very, very young age, they can start off with a very open mind. Like, say, even grade 1 or grade 2, they can start off with this block-based programming language doing very simple animations using programming logic. And over time, that programming logic sort of grows onto them, and later they're open to doing even more interesting things. Like, for example, artificial intelligence. You see APIs like IBM Watson Conversation that allow us to create chatbots, entire chatbots, in under a few minutes using almost no code. And so now you can build AI-enabled applications with the code that you know, and you can do it without actually having to know any of the backbone or the actual mathematics behind the artificial intelligence. And so again, it really sort of depends on the demographic, but really what I believe is that starting off in a very interactive way, in a very hands-on method, where people are actually working with the technology, where people are actually implementing the technology, and actually experimenting by themselves. Because, like, for example, when I was learning Swift when Apple released it in 2014, their new programming language, I didn't just learn Swift by reading a book or by watching a few videos or even, watching a course. But rather, what I did is I'd read the documentation, I'd read the courses, but at the same time, what I'd do is I'd experiment myself. I'd implement absolutely random things, like, for example, a GCF LCM calculator for numbers. I'd implement a prime number checker. absolutely anything to help me grow those fundamentals, and now I can implement, for example, technologies like AI. And so again, really starting off at that very base, like scratch, and slowly evolving at the student's own pace to other applications like Swift Playgrounds, and then eventually even, say, my book that I've written on iOS app development called Hello Swift, and then from there getting to IBM Watson. In fact, I'm working on another book on IBM Watson next, which will be sort of like a next stepping stone as to how you can get into the world of artificial intelligence without having to actually learn about all the entire back end. And so that's really what I believe, starting off really small, starting off with interactive examples, and allowing them to learn on their own with example-based learning.
So the on-ramp is easier now, and the payoff is potentially bigger. I mean, you mentioned Scratch, which is MIT program. Logo was before that. It's a guy named Seymour Papert that did it. It's the little turtles. If any of you got little kids who are now grown up, that's how they learned. But you couldn't do what you can now in this short amount of time. And then there's the workforce aspect of this. I'm throwing this. As you work, Gabrielle, with kids and Jim and Miguel, what's the honest thing to say to them about an introduction to this world? Very few of them are going to become professional engineers. Some of that low-level programming, as it already has, is going to be automated. But why is this kind of worthwhile, even though you're not, what do you say to them in terms of, you learn a little bit of coding, okay, fine, but that's a first step at most, right, into these kind of other things. I mean, what's the honest, goal that they should be, if it's in New York City or if it's in one of your after-school programs, what's the pitch to the kids? Because it's got to be more than eat your peas, right? Yeah.
Absolutely, and we've talked a little bit about it already collectively here. There's a few things that matter. First of all, it's an introduction, and they have to have fun, and they have to, enjoy an experience that hopefully will make them more curious than they were before. And then as they get a little older, it's all about the future and what's to come. And this is a different way of thinking, and it's a different way of learning, if you will, in terms of going forward. And it's going to be a part of everybody's life, whether you're, to your point, an engineer or you're working in any job in this country. This will be part of it. Science, technology, engineering, arts, and math will be part of it. So you go back to the skills you're going to need when it comes to problem solving, innovation, working together, collectively. These are all really, really important. So we look at it in terms of experience, exposure, and Tanmay is right. When you think about this with introduction, if you will, to all of this, it has to be youth-led. It has to be their peers. And it has to be project-based. You have to get your hands on it so that they're enjoying it and having fun with it. And then as you go, it's about building this awareness. So we study that, particularly with girls. And we look at our 12th grade girls coming out of a Boys and Girls Club. How do they compare to the rest of the population when it comes to likelihood they'll go on to some kind of career in this space? And we do about 3 times more than the average girl does in the country, and about double for all kids. So we track very carefully. Are they getting that awareness and that experience, and do they want to pursue it, which gives you an indication a lot of what you've done has gained traction.
Yeah, 50+% is pretty good.
That is.
This is signaling that we're done, and I think we've got another 15 minutes, so I think it's off. Yeah, it's off, so we'll ignore it.
We'll go.
Gabrielle, what, you're just a short ways along in this program now, but sort of what seems to work?
Yeah, I think so. For us, in thinking about this, we talk a lot about college readiness, and we have for our students an academic achievement, and college readiness needs to be expanded, I think, to college and career readiness, because we want to get our students to college, but we're thinking about what's beyond that, and it's giving them the skills they need to persist in college, and in New York City, persistence through our community college system is a major issue, with only 50% receiving a BA in a 4-year time frame. So how can we really expand their opportunity and make sure that our students are put on a career path? And so this is equipping them with the skills they'll need to succeed. As Jim said, and we spoke about these soft skills, critical thinking, communication. When I talk to employers, they talk about soft skills. Responsible employees, show up on time, trustworthy, communication skills, critical thinking, creativity, working in groups. Computer science education is proven, data behind it, to contribute to these skills. I think even more importantly than those hard skills. An employer will say to me, well, I can teach a hard skill, or I can teach the way we do business, but these other skills are integral to us. So it's really a holistic point of view. I believe in work exposure and experience outside of the classroom is as important as in the classroom. So we've expanded internship and mentorship and after-school opportunities dramatically for all of our students. And so within CS for All, the response has been overwhelming, I should say. As I mentioned, we piloted multi-year programs in elementary school. We were well oversubscribed. Its teachers are being trained, as I mentioned as well, oversubscribed. So the desire is there, and we have to bring it to our students. And what we have found is, if we offer it, it's my field of dreams, if we offer it, they will come. We've seen the demographics with girls and students of color. In 2 years of this program, we've doubled the number of students receiving CS education from 54,000 to 93,000, and our demographics have jumped and met that climb. We've gotten from AP Computer Science 2 years ago, 1,000 students taking it, to this year, last year's AP, 3,000 students in CS alone. So we've got to offer it, and we've got to get into every community. That is the only way we can tap in early when they're young and create that enthusiasm, and perhaps overcome the gender and racial gaps by getting to our young people early with Scratch and robotics and Legos. I've learned a lot in the last 2 years, and get to them early, and then keep offering not only computer science education, but contextualize it for them in these other opportunities.
Tanmay, let me ask you, you have people here who are involved in city and policy. If you had a recommendation for STEM advocacy, what might it be?
Sure. Now, it really kind of depends. I mean, as you mentioned, sort of STEM advocacy, one of the themes of this conference is STEM to STEAM, which is one thing that I am a huge supporter of. As you know, I love technology, but it's not just about the science, the technology, the engineering, the mathematics behind it. The arts behind it are also very important. And so, generally, what I'd recommend for the actual advocacy is, of course, as I mentioned before, bringing these kinds of subjects not just in segregated environments, like what we're doing right now. We cannot teach science separately, technology separately, engineering. We cannot keep these in individual segregated subjects. And we can't actually teach these all together as well. They need to be integrated. Like, for example, if you take a look at technologies like AI, they're the perfect combination of the science behind biological neural networks, the actual mathematics that convert those to artificial neural networks, and putting that onto technology. And then you can use arts around that. You can use this in the field of arts. You can use this in the field of engineering. You can do this. You can do really whatever you want with it. So again, what I'd recommend is starting off by bringing these sorts of STEM and STEAM subjects to schools, first of all, at a very, very young age, at a very young grade, so that people can actually get into this with a very open mind. They don't have that bias that, hey, technology or programming is something that only, a genius can do, or something that only someone who's really good at, say, math or science can do. No, it's not like that. They need to know that, and the way we can do that is by showing it to them while they have the open mind, while they have that sort of curiosity, and they have the ability to grow that curiosity. And then from there, again, combining these and actually not just teaching them in individual compartments, but putting them together and teaching kids how to actually how to use them in one individual package.
It is kind of interesting. The pitch for STEM or STEAM is a technical spin on the standard pitch for liberal arts. This is a way of thinking.
Yeah.
And it's no single language that's the lie.
Exactly.
I mean, the language, you learn a language, you're okay. I mean,
Exactly.
it's not, that's not going to work. But it's a way of problem solving that kind of enhances your view of the world. Now, one could say the same for art history, right? It enhances your view of the world. It enhances everything. But one seems to be a bit more mercenary, with more opportunity. But Miguel, let me ask you this. I mean, your advice on a policy standpoint. I mean, do you have, since it's a freebie for you now, you're out?
Well, I've spent the last 2 days talking a lot about my new role at Mastercard and how we are going to really take the approach of listening to cities and understanding what they need as we develop our responses to that. And it's interesting to sit up here and listen to this, and now it's reversed. I think what New York City has done well and what should be kind of the model is for the city to listen to the employer base and understand what those needs are. So it's kind of the other side of that coin, right? Which is to say, all these skills are necessary. They're not only necessary in the classic tech frame of, going to work at Google or Facebook, but technology is going to transform every industry, and especially in a place in New York that enjoys a very diverse set of industry. We really need to ask all those different players, not just the obvious tech folks, but all of those different industries, what is the skill set and the frame of thinking that is going to be valuable to their success and their progress, so that it's customer first, and that approach will then generate the things that are actually valuable, and I think create the results that we're all looking for, which is the pathway to that opportunity.
Gabrielle, this public-private partnerships are your world. I mean, you talked
Right.
when we talked before about changing the corporate culture, right?
Yeah.
In terms of kind of what they're going to do. What's the role for companies to play, and how is this evolving?
Yeah, Computer Science for All, our program is a public-private partnership. Why? Because we have to have the private sector and employers and the tech companies, the people creating it, using it, I couldn't agree with Miguel more, at the table with us. It's changing so rapidly. Our curriculum, we need to be on the front foot to teach our young people at the speed that it is, like lightning, changing the world. So I think it's integral to be at the table together. I also think we need culture change in terms of the way employers think about their workforce pipeline. You talk to employers all the time, and there's diversity issues, there's skills gap issues. Well, think about your workforce while they're still in school. Start developing young people and the kind of employees you want early. Be at the table with us. And I think we also need to engage the private sector to do so. And I see it starting a little bit, but an internship is still thought of as philanthropy or altruism. And I think we have to kind of change that thinking and push it forward.
I think actually our time is getting toward the end, but if there are anybody who has questions, I think we've got time for a few of those. So, if there's, yeah, sure.
Yeah. Yeah. We are doing elementary school.
Yeah,
and
should we
in
summarize
fact,
the question?
Yeah.
You want to summarize? The question was, we talked. Much of the drift here is catch them young. What's New York City, not middle school. Before then, what's New York
Yeah.
City doing?
We are rolling out computer science education throughout elementary school. It is happening. We're only 2 years in, and we have 1,800 schools throughout our system, so it does take time. We're incorporating it into pre-kindergarten, universal pre-K as well. So we agree with you, but it is just really getting off the ground, I'd say to you. Yeah.
I'd go out on a limb and say engage with people like
Yeah.
this, because he's providing that inspiration.
That's right.
The structure is important to make it replicated, but getting stories like this in
Yeah,
front of those
absolutely.
students shows them what the possibilities are.
And
Absolutely.
ditto in the after-school or out-of-school time environment. We start at the youngest age, and then you build, and obviously you have programs, initiatives that meet them where they are. And I couldn't agree more on the public-private. I mean, our private sponsors, see this too, whether it's Comcast or Disney. It starts at a young age in order to be able to give them those tools and then progress through life.
Other than to thank our panelists, I don't see any questions out there. I think, we have one back here. Do you have a microphone? Sure. I think somebody's coming with a microphone, so I think you'll be fine.
Thank you. Now I'm here. My question goes into the direction. For me, it's really a chicken egg problem. So if you don't have the teachers, how can you educate the children? So how are you engaging with the teachers? How are you training them? Because they must be ready for this. So what's your answer for this?
If you can believe it, New York State did not have a computer science certification for teachers until a month ago. It just passed the legislature in Albany, yes. You all know that. This crowd knows that. So I would say that it's actually our program and the enthusiasm and the push of CS for All that we've all been in together that has brought that change. So that's a huge step forward for New York City and the state. And you are right. The whole initiative is, the cornerstone is training over 5,000 teachers. They're being trained across the board how to integrate CS education into social studies and art and, by course, how to teach certain coding and also multi-year curriculum. So we are doing it across the board. We partner with many nonprofits you all know of to do that training. Another example of why public-private is so important. Our nonprofit partners are key to the success, and the teacher training, though, is the linchpin, and our new certification will now be able to help us expand. There were no teachers to hire, no certification. I think now with this step forward, we can possibly speed up our process.
Well,
And that
thank you. We're
Yeah, sorry.
All right.
There's just one more point that I'd like
one
to make.
kibitz.
This actually ties in with one more thing that I'm working on. There's a mentor of mine in New Zealand, and we're actually working on an initiative where not only do we develop with AI products, not only do we help companies develop AI, but we also train people so they can go ahead and train more people as well. Sort of train the trainer thing. We're working with some companies in India and New Zealand. So it's going to be really interesting. You'll hear more about that soon as well.
Well, our time, as they now insistent, is up. I want to thank the panel and the stalwart members of this audience who hung around for the end of day 3. Thank you.
Thank you.